Let's rejoin the conversation for part 3 of my interview with Dr. Joseph Urban.
So let me also maybe move to a slightly different topic, because one of the things that fascinates me about this work is not only that it requires some different technologies, but those different technologies, machine learning, mathematics, pure mathematics, and then also theorem proving have been quite distinct communities. So there are overlaps, of course, especially in individuals like yourself, but largely these are areas where I say there hasn't been a lot of cross-fertilization. And yet to make your project a success, you had to find people that had aptitude and interest in at least some combination of these areas. Can you tell me a little bit about the human challenge of bringing together a project of this size and scope and multidisciplinary nature?
Yeah, it's really a good question. So it's amazing how mistrustful and distant is the sort of statistical machine learning community and the, let's say, logic community. I would say the people who do logic, they have really a lot of trouble understanding how statistical machine learning works. Like, if you are a logician, when they taught you the first course in some proving, you are trained like hell in this sort of counterexample based reasoning. So somebody gives you a proof and you find a counterexample. So you always do this. Like, you are trained as a mathematician to always come up with counterexamples. So for a mathematician, logician, reasoning person, as soon as something is only working statistically, and they can come up with counterexamples, like you see some simple machine learner which only uses some symbolic features of some formula, you immediately come up with a counterexample why this algorithm will fail on a particular problem, right? And they sort of do not, very often they do not get the big picture, right? Like that we are starting somewhere, and instead of like manually crafting some simple heuristics, we are sort of trying to gradually learn more and more complicated heuristics in some frameworks that that might, well, typically always have some theoretical limits, but it's quite hard to figure out what are the theoretical limits, like how strong are the machine learning frameworks, for example. So it's really hard for the logic people to trust statistical machine learning, and it's the same for the statistical machine learning people. They have a lot of problem understanding logic, like that's not what they do. Like, it's some crazy axioms and whatever. Like, give me my corpus and do some training and testing on that. That's what the statistical machine learning people do. So this is really an interesting issue, how hard it is to get somebody on board and start combining both of these things. In my group, it worked in various ways. So obviously, I'm sort of the rationalizer here who tries to explain to people like why we need to do things with logic, how cool it is to do deduction, that you can generate a lot of data by running automated theorem provers, that it's much better than just some stupid natural language processing when somebody gives you the brown corpus and that's it. You cannot do any inference on that, etc. And to the logicians, like, why we need the machine learning and what is the big picture. Like, even though we might be using some very stupid machine learning right now, we have ways to go forward. Like, there are more and more complicated machine learning methods, and it's sort of up to them to come up with, for example, intelligent features that they are using themselves when they are. So one way how you can catch them is to tell them, so how did you prove this, right? Like, how did you do some exhaustive algorithm? No, you haven't. You have been trained, and your brain has been trained. So try to figure out, try to ask yourself, like, what was the algorithm you are using for doing the theorem proving? And like, except from me, like, there are the method is also to let these people talk together, right? Like, so you hire one guy who is doing machine learning, another guy who is doing theorem proving, and now you sort of force them to communicate, to be at the same progress meetings, etc. But it's not trivial. So, for example, some 5 years ago, I went to visit Google, and they started a project basically in my area. And I got the same feedback from the leader there, from Christian Segeri, who also, like, he hired very good theorem proving people, for example, but he was saying, these people, they don't buy into machine learning, and it's sort of a universal problem, but I think it's improving. Like, people are seeing the light these days.
Yeah, it's true. I mean, interdisciplinary work in any given set of scientific disciplines does seem to be a bit rare. In this area, I think it's really fascinating because the history of science and mathematics is full of quotes from famous scientists, like Einstein, of course, being the most quotable, who has all sorts of examples where he said, the idea about this mathematical achievement just came to me in a sort of flash of inspiration, an intuition. And so it's this interplay between a sort of intuitive statistical pattern matching approach that says, this just has to be true. It just fits. It feels right. And then the deliberative process of mathematics that goes about explaining why that intuition is right. Because even if you're Einstein, you can't stand up at a scientific conference and say, I just know it to be true, right? That's not good enough. You have to say, I believed passionately that this was true because it came to me while I was playing violin. But here, let me show you the detailed proof in so many steps that proves irrefutably that in fact this must be true. So when people are maybe resistant to these two modes, I'm surprised that they don't kind of look back about the history of science and see that this clearly must be, at least in some way, the process of doing science, having these two different modes of thinking.
It's a good point. Like, I think Einstein is really a great example because he came up with something so counterintuitive like relativity, and he sort of forces you to accept the solution, the theory, by doing these beautiful thought experiments, and he's sort of using deduction to force you to accept the new intuition. So you can sort of see the feedback loop there, right? Like, he has a hard problem. He comes up with a crazy solution by whatever crazy enlightenment method, and he very deductively justifies that, and people now basically go through that process when they learn physics, and they sort of accept it, and the physicists really start to think with these intuitions, right? So it becomes some part of system 1 or system 2 or whatever is the sort of terminology for this. And in general, you are also right that in mathematics, this has been an ongoing battle between differently oriented people. So there always were people who wouldn't give up mathematical intuition for any formalization, automation, etc., and who would, like Penrose, right? Like, who would actively deny and come up with complicated theories why machines will never be as good in theorem proving as humans.
But it's
then,
probably because they haven't had these two modes. I was just also there's a famous Indian mathematician from quite long ago that I thought he was also quite well known
yeah,
for coming up with all
Ramanuja.
sorts of things. What was
Yeah,
his name? Do you recall?
Ramanuja. Yeah,
Ramanuja. Yeah, he would, and I think he had some phenomenal output where he would write down these theorems without the
yeah,
proofs. A
yeah.
lot of them would be wrong, but a lot of them would later turn out to be right, and they had just sort of come to him in a dream or something.
Oh yeah, yeah, yeah. Ramanuja is a counterexample to a lot of things. Like his intuitions were so extremely good, and the thought process, or whatever you call it, intuition process, is he was doing is probably quite unexplored, and people probably don't know much about how he was getting these results. But it were other people too, like Einstein, Poincaré, like everybody could get these sort of flashes of intuition that you mentioned.
Yeah, I mean, I don't think that he's really a counterexample. I mean, to me, at least he's trying. I'm trying to make the point that this is actually common, even amongst mathematicians that we think of as being so incredibly step by step informed and rational. This intuitive approach has been ubiquitous, and it's not confined to the historical geniuses like Einstein, but it's even these different modes of thought happen all the time just to regular people. About, you realize something must be true, and then your conscious mind does some theorem proving, right? It tries to say, what are the reasons why I should believe that, even if it came to me in a flash. So this just seems to be a natural part of human intelligence, and you've done a brilliant thing by doing a very large scale concrete project to try to bring these two modes of thought to bear on some very practical and hard scientific problems.
Yeah, we try. I just one quick comment I read recently. This might be a very common knowledge today, that humans are really good at like fake justifications. So there are various experiments with the left and right hemisphere when somehow if you make like one of the hemispheres believe something, it's very good at rationalizing it by basically making up some justification. So the two processes, like the one when you have the intuition that something is true, and the one when you rationalize it, are probably pretty different processes, even in humans.
Yeah, there's really, so I've advertised kind of on this channel before Daniel Kahneman's work, Thinking Fast and Slow, which is really very accessible and details a lot of the psychological experiments like that you're talking about. That, yeah, people do have the flash of inspiration. Sort of the bad version of this is that they rationalize what they already know by inventing some truth, inventing an argument, as opposed to using the argument as a way to debug the inspiration.
Yeah.
We'll pause the conversation here and return in my next video for part 4, the final segment of my interview with Dr. Josef Urban.